Let's try to find the distance vector routing table using the least cost path from, you know, moving the packet from customer one connected to router one to every other customer on all the other routes that you have. So with this, you have to be, so now we're going for the distance vector. This was the least, the, the link state routing uh, uh, connection or path connection. This is more of the distance vector part. This is where we're probably going to be building the routing table using the next hop links involved. Okay, so customer one is grayed out or it's red out. Let me gray it out actually. Because that can't participate in the transmission since it's being used to uh, forward the message. Not like the way we eliminated R1 on this one. So I've grayed this one out. Now I have from customer 2 all the way to customer 10. So these are just customer connected to all the 10 routers that we have. And the question is, using the list cost that you have, that you generated from your Dijkstra algorithm, use that to plot out the routes that were involved in getting us to each and every single destination. And with the list part, the next hop involved. So for customer one on router one to transmit to customer two on router two, the route was, so we move from here to here, right? The route was from R1 uh, to R2, and the cost was 1 right there, 1. And our next hop was obviously R2, sorry, R2. For customer 3 connected to R3, router 3, it was from R1 to R2 to R3. So it's R1 to R2 to R3. To R3. I'm putting my lights on. And the cost was 3, right? 1 plus 2 was 3. And the next hop was R2, obviously, because you had to go to R2 to get to R3. When it came to customer 4 on R4, there was direct connections, which was 2, and it was R1 directly connected to R4. So our next hub was directly R4. Customer 5 on R5, it was 1 plus 1, which is 2. And the path was obviously R1 to R2 to R5. So our next hub still remains as R2 I'm just basing off this from the new uh, shortest path tree that we have. So for 6, let's see, for 6, it was this path. It was from R1, R4, R7 to R6. So R1, R4, R7, right? R7, R7 here. We got to R6. R6. And the cost was 2 plus 1 plus 1, which is 4. And in this case, R4 was the next hop, because that was the immediate connected router. For 7, it was 3, which was from R1 to R4 to R7. So R1 to R4 to R7. And that was what, 3, right? Yep, it's 3. And the next step was R4. For 8, it was this route from R1, R2, R5, R8. So it's R1, R2, R5, to R8. And how was the cost involved again? 1 plus 1 plus 2, 4. And our next step was R2. For 9, it was just the same. It was this route just to get to 9. So R1, R2, R5, R8 to R9. R9. And the cost was 7, right? It was 11437. And we had R2 as our next hop. And finally, customer 10 connected to router 10. It was this route that gave us the least cost, which was 4, right? 2 plus 1 plus 1, 4. And it was from R1 to R4 to R7 and to R10. Oh. And our next hub was R4. So this is literally our distance vector routing table using the least cost path tree that we had from the Dijkstra executed tabulation. or algorithm tabulation. So this would be a tabulated least cost distance vector routing table. So you have your routes that corresponds with their least cost, and then the next task involved. Okay, so this is a typical, routing question that you might come across if you're given a routing table. So if you're given a network like this, you had to basically come up with the least cost. You have to basically execute the Dijkstra shortest path algorithm for a linked states routing, given the customer orientation within this given network. And you should be able to derive all the various uh, costs associated with moving the information from a given scenario from its point to other points within that network that you have. And in this case, it was customer one connected to router one and forwarding packets to all other customers connected to every other router within this node or within this network nodes. Okay, folks, so you saw the arrangement. It's nicely organized. I would advise you to download the this application if you have get a chance to the diagram application, or if you can even use uh, if you have Visio, you can use Visio or other simulation softwares that can just get you the arrows that you need, and then your uh, text to label out your route and what have you. And then you just save as an image and introduce it within your work. Okay, so folks, that should wrap it up for Dijkstra shortest path algorithm um, execution, building, and then using that to uh, develop the routing table for a distance vector routing algorithm. Okay, we're good. So from here, we got to this based on execution, and then from the tabulated execution, we build the new shortest path tree. So coming from this highlighted least cost that we got, and then from there we were to build our new distance vector. So we basically moved from a link state to a distance vector. Okay, and these are all under intra-domain routing. They are not inter-domain, but intra. They're internal. Okay, most of your least cost algorithm are purely based on intra-domain transmission. The inter-domain are the ones that use the path vectors. Okay, where you assign tags to implementation like BGPs and what have you, border gateway protocols, exterior gateway protocols, what have you. But these are mostly for your RIP, um, uh, most of your interior routing protocols. Okay. All right. Okay, so that should do it, guys.